Hi everyone, in this lesson we're going to learn how to rationalize the denominator of a surd. As usual, we're going to start from the easiest and proceed on to do a more challenging questions. So let's begin. When you talk about rationalizing the denominator, it's just a way to make sure that the denominator of the fraction becomes rationalized. Rationalizing the denominator of a surd simply means that we make the denominator of a fraction become a rational number. How do we do this? This process usually involves multiplying the top line of the fraction and then the bottom line of the fraction by the denominator. So let's get started. We know that the denominator of this fraction is root 2. So I'm going to write the fraction again for root 2. And we're saying that the process is we want to multiply the numerator of the fraction by root 2 and multiply the denominator also by root 2. Why are we doing this? We do know that anytime we divide a number by itself, we get 1. So if we divide 2 by itself, we're going to get 1. Same way, if we divide root 2 by itself, we're going to get 1. And again, when we multiply 1 by a number, the value doesn't change. So 1 times this fraction 1/3, it remains 1/3. 1 times 2, the number remains unchanged, 2, right? So root 2 and root 2. Root 2 divides root 2 and it gives us 1. So here we have 1. When we multiply this 1 by the fraction, the value still remains unchanged. Just multiplying the fraction by the same expression root 2 over root 2 is equivalent to multiplying the fraction by 1. The value still remains unchanged. Nothing has changed. So let's continue. We know from the previous lesson that 4 times root 2 will give us 4 root 2 over 4 root 2 over root 2 multiplied by root 2. We're going to have root 2 squared, which is 4 root 2 over square takes away the roots, give us 2. These 2 can divide the 4. They are all whole numbers, giving us 2 root 2. That's it. Let's try question 2. 6 divided by root 2. And then we multiply this fraction by the denominator, which is root 2. We multiply the top by root 2 and then the bottom also by root 2. As I explained at the top, root 2 divided by root 2 will give us 1. 1 times this fraction is the same as that, so the value hasn't changed. We keep on doing it. By the way, if you're having difficulty how to multiply surd. I'll put a link down below so you can always go back and review. 6 times root 2 is 6 root 2 over root 2 times root 2. We're going to have root 2 squared, as we did before, which will give us 6 root 2 over 2. 2 will, the square is going to take away is going to cancel the square root. All right. Which gives us 2 divided by 6. We have 3 root 2. That's it. Let's move on to question number 3, which is quite different. Please note that for this question, the denominator can further be simplified or can be broken down into 2. So this is the same as 3 root 2 divided by root 5 times root 2. We have root 2 here, we have root 2 there, so root 5 root 2, sorry, root 2 will take our root 2, which is 1. So we're going to have our numerator to be 3 and denominator to be root 5. Now have a look at something. What we have here is the same as question number 1. So we can move on as we did at number 1. Right now we know the denominator is root 5. So we're going to multiply 3 root 5 by root 5 and then over root 5. 3 times root 5. We have 3 root 5. 5 times root 5 is going to give us root 5 squared, which is 5. And that's it. We're done. Let's solve for question 4. Our denominator is a surd, which is root 6. So we have to multiply the whole fraction, the top by root 6 and the bottom by root 6. So 3 plus 2 root 6 over root 6. So we need to multiply the whole thing here, which is the top, by root 6. Then the down also by root 6. It's the same thing that we're doing. Now we're going to expand the top. You've done expansion of surd. You can check the link at the description below to learn more about how to expand and simplify surd. 3 times root 6 is 3 root 6 plus 2 times root 6. 2 times root 6 squared over square root of 6 times square root of 6 is also going to give us square root of 6 squared. Two, 3 times root 6 plus we have root 6 squared is going to give us 6, and then times 2, which is 12. So plus 12 divided by 6. All right. So here you can see that 3, 6, 12, they have the common factor, right? Which is 3. So this can be further simplified. 3 goes here 1. You don't need to write the 1. So we have the square root of 6 plus 3 goes into 12 4 times, and then 3 goes to 6 2 times. That's it. Let's consider another example. Here, the denominator is root x. We multiply the top, x, square root of y. We multiply it by square root of x. And then we multiply the bottom, which is root x, also by root x, which is x root y times x will give us x root square root of yx. In algebra, you normally put the first letter first, so s comes before y. So we have x square root of xy over root x times root x. Again, we have x. Let's see. S can take x out. So x divided by x gives us 1. No need to write the 1. So we having the final answer to be root x y. That's it. Let's have a look at what we call the conjugate or conjugate of surd. By the way, what's the meaning of conjugate? Let's say we have root a plus root b. Its conjugate is root a minus root b. The conjugates, we only change the operation between them. This expression involves two terms, binomial. So we just change the operational sign. The plus becomes minus. If it's a minus, it's going to become plus. So if we have 1 minus root 2, its conjugate is 1 plus root 2. That's all. Sometimes we may be given questions that involves conjugate. So let me clean up a little bit and let's move on. Let's consider this question. 1 over 3 plus root 5. All right. In this case, we're not going to do the things as usual as we did to the previous question. Remember, for the previous questions, the denominators were only single, one expression. But this time, the denominator involves two terms, binomial. What do we do then? We need to apply the term conjugate, as I've just explained. So we need to find the conjugate of 3 plus root 5, which we know is 3 minus root 5. So getting this conjugate, we can multiply both the top and then the bottom by its conjugate. So this can be written as 1 over 3 plus root 5 times we multiply the top by its conjugate, the conjugate of this, which is 3 minus root 5. We do same thing at the bottom, 3 minus root 5. So you're going to multiply 1 by this, and then the denominator also by the denominator. So this is the same as 1 multiplied by 3, and then also multiplied by negative 5 will give the same value, which is 3. 1 times 3 is 3. 1 times negative root 5 will be negative root 5 over 3 times everything here, and then root 5 times everything here. So which is the same, which can be rewritten as, we take this 3, and then we multiply it by everything here. So 3 times 3 minus root 5. After that, we take root 5 and multiply it by everything. So plus root 5 times 3 minus root 5, which is equal to 3 minus root 5 over 3 times 3 is going to give us 9 minus 3 times root 5 is going to give us minus 3 root 5. We haven't finished. Let's go to root 5 times 3. So it's going to give us plus 3 √ 5. We have root 5 + 3 = 9. 9 + 3 = 12. 12 + 3 = 16. 16 + 3 = 24. 24 + 3 = 26. 26 + 3 = 28. 28 + 3 = 30. 30 + 3 = 40. 40 + 3 = 50. 50 + 3 = 60. 60 + 3 = 70. 70 + 3 = 80. 80 + 3 = 100. 100 + 3 = 200. 200 + 3 = 400. 400 + 3 = 500. 500 + 3 = 600. 600 + 3 = 700. 700 + 3 = 800. 800 + 3 = 900. 900 + 3 = 1,000. 1,000 + 3 = 1,000. 1,000 + 3 = 2,000. 2,000 + 3 = 3,000. 3,000 + 3 = 4,000. 4,000 times negative root 5, which is going to give us negative root 5 squared, which is the same as three minus root 5 over negative 3 root 5 plus 3 root 5 will give us 0. Don't forget that this square will cancel the square root. So, which is going to give us 9 minus 5, which is equal to 3 minus root 5 over 4. That's it. But don't forget, this can also be written as 3 over 4 minus square root of 5 over 4. It's the same thing, but you can. Let's practice more on this. Let's consider 1 over square root of 3 plus 1. How do we deal with that? We want to move a little bit faster. This is same as 1 over root 3 plus 1, and then we multiply the top by the conjugate of this. We already know the conjugate. The conjugate of root 3 plus 1 is going to give us root 3 minus 1. Then we multiply this denominator also by the conjugate, root 3 minus 1. All right. As we did it earlier on, this is going to give us the same value, root 3 minus 1 over, as we did previously, is the same process. So right now, let's fast track the process a little bit. Let's multiply them directly. We know root 3 times root 3 is going to give us root 3 squared, which is 3. Then root 3 times negative 1, we're going to have minus root 3. We take this one and multiply through. So 1 times root 3, we're going to have plus root 3. 1 times negative 1, we're going to have minus 1. That's it. This is the same as root 3 minus 1 over root minus root 3 plus root 3 is 0. 3 minus 1 is 2 over 2. That's it. Don't forget, you can also write this as root 3 over 2 minus half. All right. Let's try another one. 1 over 1 minus root 5. Let's see. Same way, we multiply the top and the bottom by the conjugates. 1 plus root 5. This is 1 plus root 5. Okay, let's go. As we've done earlier, this is the same as we distribute 1 here. We're going to have 1 plus root 5 over 1 times 1 is 1 squared, which is 1. 1 times root 5 is the same, so plus root 5 minus root 5 times 1 minus root 5 minus root 5 times root 5 minus root 5 squared. The square is going to cancel the square root, so that will give us 5, which is 1 plus root 5 over root 5 minus root 5 is 0. 1 minus 5 is negative 4. That's it. And that's our final answer. Thank you so much for watching this video. Please consider subscribing to this channel. Thank you. Goodbye.